So what I want to talk about today is the upcoming versions of Groovy. So Groovy 2.4 has been out for quite some time now. It's nearing end of life and we haven't even got 2.5 final out. We've been putting a lot of features into 2.5 and we've been working on 2.6 and 3. In hindsight, we probably should have just got 2.5 out because we've been distracted looking at the other versions, but I'll go through all the details about what's coming up in all the different versions. Again, thanks to OCI for all the work they do in the Groovy and Grail space, and a little map showing you where I live. I've got another little map coming up, a little geography question for you about halfway through the talk. So we'll see who's still awake by then. So Groovy's been still increasing in downloads. It's over 4 million downloads every month now, so it's over 50 million downloads in last year, and it's looking to eclipse that this year as well. So it's looking very healthy. All the new versions that are coming up have got a lot of new features, so we're expecting the interest in Groovy to keep going. What I want to briefly go through is some of the features that are in 2.5. So Beta 3 is out now. The release candidate 1, I was meant to be announcing to you today that it's out and finished, but I've been working on slides the last few days and a few bugs have cropped up, so I'll probably try to release it sometime this afternoon or tomorrow morning. And then Apache has a voting process, so it'll take 3 days to get voting. So the first release candidate of 2.5 should, by the time I get off the plane going home, the voting should be finished and I should be able to release it. So it should be out early next week. But if you go and get Beta 3, it's got it's fairly close to feature complete. Okay. I'm also going to talk about 2.6 and 3. Basically, version 3 of Groovy is all the features that are in 2.5 plus the new Parrot parser. Okay, the new Parrot parser is a new parser that is a brand new iteration of the parsing technology, and we've implemented a lot of new features, and I'll go through those today. It'll require JDK 8 as the minimum JDK to run. Some of our users have requested that they love the Parrot parser, but they're still stuck on JDK 7. So what we've done is we've made a version 2.6, which is just 3, backported to JDK 7, minus the features that just don't automatically backport. Okay, so we're not expecting many people will even touch 2.6. Most people are going to go from 2.5 straight to 3. Those who are stuck on JDK 7 will use 2.6. We're not going to invest a lot in 2.6. So it'll be an interim stopgap. If other people in the community need a bug fix, they can happily submit pull requests. We'll add those in, but we'll probably leave 2.6 alone once we get the first release out. So you should see release candidates for 2.6 and 3 towards the latter half of this year. We should be getting close, but maybe not quite ready for final release by the end of the year. So it'll probably be early next year. Let's have a look at some of the features that are in 2.5. So there's a whole range of new AST transforms that have been added and a whole lot of improvements to the existing ones. There's a bunch of miscellaneous improvements. There's some improvements into how it runs on JDK 9 and 10. So the Groovy test suite has been happily running without errors for over a year on JDK 9 and 10. You just get a whole range of horrendous warnings in your log files at the moment. There's nothing we can do about those warnings for the time being. I can talk to people after how you can minimize those warnings. We can get rid of the warnings, but it means putting in some brutal JDK 9 switches, turning off all the warnings. And we don't want to do that because then if we actually introduce new features into the Groovy code base that won't be compatible with JDK 9, we won't know about it. So we'll leave those warnings on. There's ways to minimize those and ways to actually get rid of them if you want to in your own environment, but that's not for today. Here are the Groovy AST transformations that are in 2.4, the blue ones. The new ones are in green in 2.5, and there's even a Groovy doc one that the Parrot parser enables in 2.6 and 3. So as you can see, there's quite a lot of new transformations there, but in fact, many of the blue ones that you see on the left-hand side there they themselves have had improvements. So if I just take one, the Topol Constructor, well, I'll do that very shortly. The two big things, canonical and immutable, they're listed on the left-hand side as blue. They've been totally reworked, and I'll explain that shortly. But many other ones have got new annotation attributes so you can customize them. So just take Topol Constructor. It used to have about 8 annotation attributes you could use. It's now got another 7. So many of the annotations are much more customizable than they were before. So often you'd find that you could go and do include super properties on one of the annotations on a 2-string or something, or not. Well, you couldn't do it on a 2-string, but you could do it on the canonical or something like that. And now you'll find that a much greater amount of commonality amongst all the annotations about what features are supported. So in fact, the code base has actually been refactored a lot for all the transforms are now often using common code to support the features. So you're going to get the same list of super properties, the same list of super fields and everything, because it's spread throughout all of the transforms. There's been a lot of rework there. It's all tidied up. So I said that canonical becomes a meta annotation. What does that mean? So the way Groovy transforms work is there is an annotation that triggers the compiler to go and do extra stuff. But the annotation collector or meta annotations is a pre-step that occurs. So what happens, rather than canonical being one of those special annotations that triggers a special transform, now canonical just gets replaced by the things that it used to logically represent. It used to logically represent having a 2-string, a tuple, and a equals and hash code annotation, but it used to have its own transform that would actually go and call into the other transforms to do its work. Now it actually gets logically replaced early on in the compilation process with exactly those 3 annotations. Now why is that a good thing? What it means was canonical didn't used to support all of the annotation attributes that the other ones used to support. And you could have a sort of a bit of a manual hack of manually placing some of those additional annotations into the code base, and we actually had special code that inside the canonical transform that would go and look for these other annotations and do special stuff. But what happens now is it just gets replaced with there's an algorithm that does merging and other things as well. And now any of the annotation attributes that could be visible on any of the sub annotations can now appear at the canonical level. You don't need to go and do any special work for that to happen. So the annotation collector is a very, very powerful mechanism in that regard. What it also means is if you like canonical, but everywhere in your organization you do some small tweak, you can go and write your own my canonical, or my company canonical, and put in different combinations of features. And then you can use that right throughout your code base, and you'll get a standard set of patterns for all your objects. Or if you can do one for all your domain objects, one for all of your other objects of different types, so you can customize what features each of those things might need to have. So the power is now in your hands to customize all of that rather than just whatever we put into canonical. Okay, if you go and look at the, it's how do you do your own? Well, you do something very similar to how canonical, this is the entire code inside canonical.groovy these days. Okay, so it is, you can see there's an annotation collector annotating canonical, and it just says, I'm a collector, and whenever you see me, go and replace it with these other list here. And there's a special collector mode, which is, you don't need to worry too much about that. I'll jump forward and explain that. I'll explain that in a few slides' time. But it basically tells what to do if you see both a canonical and a tuple constructor. How do you merge them? Do you ignore one of them, and so on? Okay, here's just some examples. And what you used to have to do if you wanted to do an include names, it used to be available on toString only, but not on canonical. So you'd have to go and manually spell them out or do canonical as well as toString. Now you can just do toString at the canonical level. What does the immutable is also now, and this is fairly recent, is now also a meta annotation. What does immutable get replaced with? Not just three things, but this whole list. And what we've done here is actually allowed immutable to be far more customizable than it ever was before. And I'll show you some examples of that. So this is in fact how all the things that immutable used to do, but it used to be all hard coded together. And perhaps, so one of the things it used to do is give you a map constructor and would also give you a no-arg version. And now you can, like, if you don't like that, you can turn off the no-arg version. Or if you don't want to include super properties, you can turn that off. So you can go and very, very easily customize what immutable is doing for you. And I'll show you some more customizations shortly. Immutable handles optional. So one of the things that you'll, if you think nulls are evil and you want to use optional, then you can happily do that with your immutable classes now. The way immutable properties are handled is now fully customizable. So remember, if you remember your back to your effective Java, the logic that you would need to write an immutable class by hand, there's a whole lot of things you need to do, defensive copy in, defensive copy out, getters, no setters, and stuff like that. When you're creating those, all the getters and the constructors, you need to be doing the defensive copying and so on. That's all now encapsulated in a handler class. And there's a default one that Canonical actually uses that you don't need to even see it because it just happens. You can override that. There's an immutable property handler there. If you don't like that, you can actually go and supply your own. So you can actually go and use Guava immutable classes. You can use persistent collections. You can use a range of other different things as the base for how you do your immutability. All of the new date and time classes that replace Java util date, they're all, nearly all immutable, so all the ones that are recognized now, so that happens automatically. Here is how you can override so here I'm overriding the property handler, and now any collection that I put inside my immutable class, rather than using the unmodifiable variants that Java supplies you with, which is what immutable does, it actually goes and uses the Guava, so it replaces it with a regular immutable list as you're building up your classes. So if that's something that's important to you, you want to customize it, you've now got that capability. There's an example using the optional. Those slides probably should have been around the other order, but anyhow. Obviously, when you're using optional, you don't want to sneak inside the optional a class that's mutable. That would not give you a mutable class, so that's also detected as well. One of the other things that's now done, we've got compile static that checks our code, but what if you've got typos inside your the names that are inside your annotation labels and so on? So here I've actually got a name inside my class. The property name is first name, and I've got a excludes equals first on my toString, and it should obviously be first name. And I was obviously doing this at 2 a.m. in the morning, and I left off the name bit. Previously, that wouldn't be detected at compile time, and it wouldn't exclude anything because nothing matched first. Now that'll actually report as an error when you're compiling, and it'll say property first does not exist and so on. And that facility is through all of the built-in annotations, and there's some libraries that you can call if you're building your own annotations, and you can get the same support for yours as well. There's a defaults annotation that's on Topol Constructor now, which is another very useful feature. To know what that's doing, you've got to sort of understand how default parameters are supported in Groovy. So when you put defaults equals true, which is the default for Topol Constructor, when it goes and gets all your properties and it's creating your constructor here, we've got from port, to port, and leaving, it goes and creates defaults for those. And because I didn't bother filling in anything in my class here, they'll all be null in my case, but these could actually have some sort of sensible default values if that made sense. Then, so that's what the transform does. Then what happens is Groovy, normal Groovy compilation would take over, and when Groovy sees any constructor or method with the default parameters, it'll go and give you the overloaded variants for those. So it'll give you one version of the method with all three parameters, one with two, one with one, and one with none, and it just passes through the null in this case, or whatever the value is, through to the next layer, the way you would do it by hand. Now that's actually a very useful feature, and that's always been the default. But if you're using a dependency injection framework or something like that, it's expecting just one constructor there, and it doesn't like all these extra constructors, it doesn't know where to inject, so you can turn that kind of capability off. So there's lots of features like that. So here we're going to get one flight constructor, but three cruise constructors, and so on. There are now pre and post closures that you can supply to the Topol Constructor or map constructor annotations, and they get injected into your constructors before and after all the other code. Okay, so you can do validation or various other changes that you might want. There's a visibility options. It's not really a transform, it's sort of like a helper. It's a marker it contains some metadata that a lot of the, several of the AST transforms know about. So if you're creating constructors, I'm going to tell you about named variant later on, map constructors or tuple constructors, you can tell it. So the default when you're, well, there's defaults when you're using these things, but if you want to override the defaults, this visibility options is supported. And it actually is very powerful. You can make it just do visibility private on things happening at the constructor level, or you can pick one particular method that you're doing stuff on and make that one protected, or whatever it might be that you want to do. So there's a whole lot of things that you can do here. Map constructor. So Groovy, when you use Groovy's named arguments, it actually relies on there being a no-arg constructor there, and then what it does is it calls the no-arg constructor and then it calls setters. Now you don't see that's what the code that the Groovy compiler generates for you does. Conceptually, you just think, oh, I've got name parameter support here. So that's very, very powerful, but there's certain things that if you want to have final fields or so on, there's no point in calling a no-arg constructor, and it might be setting certain things, and then you go and call setters, and it's just not going to work. So you can actually put map constructor now on any of your classes, and it'll build you the kind of version that you would do by hand, and this allows things like final fields and so on. So when you need it, it's there, and it's the thing that Immutable used to do for you automatically. So now it under the covers is exactly what Immutable is going to be using. There's an auto implement annotation. Groovy's got a lot of facilities for dynamically creating sort of proxy objects. So you can create a map, and the map can have keys and then closures, and then you can treat that as an object. So I can create a map that's got a has next and return a closure false, and I can say as iterator. And then as far as the rest of the world's concerned, I went and created an iterator object, and I can go and iterate through it, whatever I need to do. So Groovy's got all these powerful mechanisms for implementing dummy objects. So here I've got iterator, I can have any interface there, and I'm implementing dummy versions of things dynamically. So now you can do all that kind of thing at compilation time as well. So if you put auto implement on a class, whatever abstract methods are in that it's extending or inheriting from its interfaces will all be given dummy implementations. And there's, you can make the dummy implementations return null or default values, so it'll be false for booleans, zeros for integers or whatever. Or you can make it, I won't bother going through all the things, or you can make them throw exceptions. So there's facilities to support exceptions. So you can have unsupported operation exception automatically happening on all your dummy implementations for the methods you don't want to support, for instance. There's an auto final annotation that'll put final automatically on all of your method and constructor parameters. So if you're from a school of thought that says I want to have final everywhere so that I get maximum feedback if I go and try to ever change one of my parameters and so on, that would be sometimes regarded as poor style. Auto final will just put that on there automatically. Won't go through that. Delegate, there's a version of delegate. You could always put delegate on any of your properties or fields. You can now put delegate on a getter. Okay, so if you've got something here, I've got a get full name. There's no full name property or field, but I can put delegate on the getter, and it'll actually be delegating to this. So when I create a new person, it'll behave in some ways like a string, but the string full name is the one that I'll be checking against. And so I can take my person and do equals ignore case, which is a method on string, and check it against this thing here. Named variant is a way to, I can go write a tuple constructor or a tuple method, put named variant on it, and it'll generate a map version underneath the covers. Okay, now why would I ever want to do that? Often you want to have a map version of methods or constructors so you can have friendly named versions that you're calling from your code. So you can have friendly looking ways to call into that method or constructor. But if I go and write that, and Groovy will support you writing one of those manually, if I do go and write it manually and I've got map, I lose the ability for the compiler to give me feedback on types and so on, because it's just map, and it'll be map of object. String to object, and I won't get much type information. What happens here is that I actually made this constructor private, so no one else will see it, but I make it fully typed. And it'll have, so I've got just ints here, it's fairly boring, but now all the code that's inside here, if I put compile static on this or whatever, or type checked, the compiler will do all the right things type-wise. But because this is private, no one else will ever see that. They'll only see the map-friendly version. But the map-friendly version maps directly into this one. It just calls into this one. So all the code, all the business logic that I've written has been type-checked, and all the users of my class will have the friendly map version. Okay, and it actually does a little bit more. That's going to allow. It's not all turned on yet, but you'll actually be able to get type checking assistance for the caller as well. But that's not quite finished yet. So I'll talk about that some other time. Macros. So I've shown you a whole bunch of AST transforms. To go and write those today, you go and use Java code, and you go create a new class node, and then put a new method node in there, and put a parameter on the method. And so you have all the data structures that the compiler knows about. You go and manipulate those inside your AST transform. Macros let you go and write all that kind of manipulation code for all the stuff the compiler knows about, do it all in Groovy. Okay, and it goes and converts to all the underlying things underneath. So if you like, it's trying to allow the average Groovy programmer to be able to do all the kind of things that those AST transforms are doing much easier. So yeah, that's the kind of thing that you would typically write. And there's actually shorthands for this, but that's for another day. That's the kind of code you used to write. Now you can just write this, and you'll get the equivalent. And in fact, I could leave off return and other things as well, and it'll automatically put those in. You can do variable substitution. So if I've already gone and done part of what I want to do, using the compiler abstractions directly, but I want to do the rest of it as a macro, I can, and I can put in little $V substitutions, so I can magically insert stuff. I've pre-digested this already, place that in here, and the rest of it gets parsed as a macro. You can make it happen at different phases of the compiler if you wanted to check stuff. There's restatements and expressions and other things that it can return as well. You can actually have a whole class as a macro rather than just a statement or expression, and there's a mechanism to do that. And there's a very, very powerful matcher mechanism as well. So here I'm creating a reference, which is a macro 1 + 1. So that just converts that to the expression that the compiler would see if 1 + 1 ever occurred in your code. So that's just some sort of reference. What I can then do is check. I'm creating a transform here, checking expressions that get parsed in, and the way the compiler works is it's running a whole bunch of these transforms, and it just calls you at the appropriate time. So I'm going to get parsed in some expression that needs to get checked against something. And what I can do is check if, with the matcher, astmatcher.matches, does the thing that came in match my reference? And if it does, I can replace the thing that has just come in with a new bit of code. What am I going to replace it with? 2. So this is doing compile time, inline, constant optimization. So it's looking through your code, looking for 1 + 1, and it's replacing it with 2. So it's making you don't need to calculate those at runtime if you don't want to, if you want to do this kind of optimization. Now, and I can put placeholders in there instead of 1 + 1. I can match anything in there, so I can actually optimize this to match anything, and I could do the calculation and make this a general purpose constant expression optimizer. So that's very, very powerful. So using these macros, there's a whole range of things that you can easily write. So there's you can go and look up a bunch of these. There's a website reference there. There's several more in addition to the ones I'm going to show you. Someone's written a match macro. So this is kind of the equivalent of pattern matching. It's kind of just a slight improvement to Groovy's got a very, very powerful switch statement. This match thing is a slightly more powerful, well, a different variant of that with some nice features. If you like the way Spock does its little tables, then there's a do data macro. And so this is allowing you to have these sorts of Spock-looking data expressions inside your own prod code. So not a test, it's inside your own code or inside your own scripts. You can have code that looks like this. And so you just go and use the macro that someone wrote. Just a few more features. We want to get onto Parrot parser, and I'll run out of time if I don't go through these really quickly. There's support for repeated annotations, which is a feature that Java supports, so we've got support for that as well. There's an example there that shows that, but you don't need to worry too much about what it does. You just need to know Groovy supports it now. Method parameters. So there's a minus parameters switch that you can give to the Java compiler that normally what the Java compiler would do, unless you've got debug turned on or whatever, it throws away the names of your parameters. And so you get things like arg0, arg1, arg2, etc. when you decompile the class. If you put minus parameter in with Java, it keeps the names of all your parameters, like 1, 2, and 3. Groovy's got the same switch. And you can, if you're using any of the runtime compilation classes, you can configure that as well as on the command line, as well as through the Ant task as well. Annotations in more places. So this is something that Java has support for. Groovy's got partial support for this in 2.5, and some of it requires the new Parrot parsers to get all of the features here. So if you want to have a multi-dimensional array of non-null arrays of non-empty arrays of read-only arrays of items, you can do that kind of thing with the Parrot parser. So you can have non-empty array list of non-negative integers that implements a non-null closable interface. If you want that kind of thing, you can support that. It's not all turned on yet in the compiler. Java doesn't turn any of that on in the compiler. It allows other checker tools to walk the code. Groovy now supports putting all those annotations into the code base and nearly got everything there to pull it all back out at runtime. You can have grab when you're using. There's a with. You've probably used with before. So if instead of doing p.friend, p.first, p.honorific, p.last, etc. in some expression here, I can go p.with, and then inside this expression use all the properties of p directly, and whatever this expression returns will be what with returns. So you can still support that, but quite often what people want to do, when they'll have the expressions like this, but then they'll want to actually return the original p. So you'd often see things like this, and then at the very end it would have return p, or just p, semicolon p in this case, because I'm all on one line. So now with the tap, and the tap is exactly like the with, but it automatically returns the original thing. So what this allows you to do is sort of have a pipeline of things. So here I'm creating a new person, .tap, because it's got mutable fields, I can set them here, and then I might go and do tap again and do some validation, and then might do tap again, then print stuff out. So depending on what your use case is, sometimes tap is exactly what you want, sometimes with is exactly what you want, but you've got both options there. There is improvements to Jaxby marshalling, improvements to the CLI builder. You can now specify your command line options that CLI builder would use using annotations. There's lots of customization for JSON. Here is the geography puzzle I promised. If you could stick your head into the earth and go through the center of the earth and pop out the other side, what's the opposite side of the world to Spain, to Madrid? Do you know where that is? New Zealand. Very, very good. So you'd pop out in the middle of the North Island in New Zealand, and I'm lucky that I'm much, much closer than people in Auckland to Madrid, but not many other people in the rest of the world. So there we go. So that's where I live in Brisbane, just in the middle of 3 hours across from Auckland, across a little walk across there. Okay, let's look at the stuff that's in 2.6 and 3. As I said, 2.6 is just a backport of 3, but with stuff dropped out that doesn't automatically backport. So we're not doing any retro Lambda support or anything like that. Stuff that goes automatically back is in 2.6. All the parser is in 2.6 more or less. Otherwise, it's 3 is the one we really want to focus on. So if you're stuck on JDK 7 and you want to start using some of the Parrot parser, we really feel it's more of a sort of interim porting stage rather than a platform we wanted to have sort of long-term support on. But it's there, and we'll do at least one release of it, and we'll probably not concentrate on it after that. Okay, let's dive in and look at some of these improvements. So some of these are just catching up, well, not catching up, but supporting features of Java that in some cases we actually thought were ugly, or there was reasons why because do while used to conflict with how closures were mapped in the grammar. We're now smart enough to be able to detect the two. So the Parrot parser will let you do whiles. So not many people use do whiles versus whiles, but if you want to have that capability, it's there. Groovy supports the classic for loop, but it never allowed you to put multiple statements with a comma, multiple expressions with a comma in the 3 different parts. So you'd have the first part to initialize, then the sort of loop test, and then the iteration part, and you have semicolons dividing those, but Java would let you have expressions with commas in each of the 3 parts. Now you can have those in Groovy as well. Groovy supports a multi-assignment, so I can assign both X being a string and Y being an int with an expression like this. Now, here it doesn't make a lot of sense. I could just easily have 2 declarations, but this might actually be a method call that's returning a tuple of things. So there's lots of times when it's a very, very nice feature to support these multi-assignments. You didn't used to be able to support that in the for loop, now you do. So you can have that in the for loop as well. Array initialization. So Groovy's always supported using the square brackets instead of the curly brackets for array annotations. Now, for the cases where you've got the type in front, we can detect that now as well, and you can use the old style as well. So a lot of this stuff is all about cutting and pasting my Java code, pasting into Groovy, and it's just going to run exactly as is. So that's what some of these improvements are all about. The identity operator. So here I've got a cat. I've got a copycat, which is just another reference to the same instance. And then I've got a line, which is a new instance, but happens to have the same properties. And because I've got an equals and hash code here, I'm going to be testing equality on properties. I'll find that they're logically equivalent, cat equals line, but I can now check identity as well. So I can check that the cat and the copycat are the same instance. The cat and the line are different instances. There's a not instance of and a not in. So rather than having sort of lots of bracketing of nots and things like that, which obscure what you want, there's just a slight little improvement there. There's an Elvis assignment operator. So there's a little bit of dupe here. I've got name equals name, and if that's not assigned, I can make it hydrogen. I can now just do it all in one hit, and it's a slightly more compact form. Okay, so it's all very simple things, but they can make certain expressions look a lot simpler. There's safe indexing. So you can see here I've got question mark square brackets 1. Basically, if my array is null, this expression is going to return null now. Okay. So this is kind of simplifying. If you don't want to go and use optional or whatever and represent these kind of null sort of scenarios using that kind of feature, you've now got all the things to support it in the traditional way as well. Try with resources. So there I've got some resources. The only reason why I'm defining my own is because I want to keep track of whether they were closed or not. And now I can just use the try round brackets, list a bunch of resources and do something with them. And then I'm going to check that it did get closed. And in fact, it does get closed, and that the string did get copied across from one resource to the other. And you can also leave off the types. Java wouldn't let you do that, but Groovy lets you do that if you want. So this is all fine. Again, it helps for cutting and pasting code. Just remember, sometimes the Groovy's got better ways with its internal iterator type things in its I/O and resource extension methods that are better than the try with resources anyway. Nested blocks. So if I just do curly brace, I can put that anywhere inside my code, and I've got a new scope. And I can define a variable that's appearing outside and they don't conflict. Okay, so there's some examples there. It doesn't happen very often, but Java supports it, so Groovy does too now. The big one, Lambdas. So you can now, so Groovy has always supported, well, not always, for several years now, Groovy has supported using things like Java streams, but what it would do is it would coerce closures into the functional parameters and things that the streams were going to be supporting. Now, and so you'd have closure syntax here. You'd have curly braces, and what you'd have is a closure would be the parameter that you're passing into filter here, and that's what's going to get called. You'll actually get a coerced version of that that's going to be passed into the filter as the parameter there. Now you can actually use the native Lambda syntax here if you want. So this is what you'd put in Java, and yep, I'll show you some. There's if you've got this inside a compile static, you'll actually get a native Lambda instead of the closure. So that can be vastly more efficient in certain scenarios. It won't support other things. And there's all the different flavors there. So there's versions with and without parameters. You don't need braces on certain versions. You can have no args. You can have default parameters, which is something Java won't let you do. Groovy will let you support that, and so on. So there's a whole range of different ones you can support. Method references. You can have class-based and instance-based method references. Okay. You can use them, you can have constructors as well. So random : new is a method reference to the creating a new random instance, and then I can call that. I can have an array of integers, I can have a multi-dimensional array of strings, and so on. You can have them in your own class, so I can have an animal class, and I can create, that I've got defined here, and I can create new instances of that, and so on. And all the normal animal : toString is going to call the toString out of canonical and be passing that through the Java streams operators here. Okay, just a couple of quick other things, then I'll be finished. One of the other things that is supported is Groovy.comments as metadata. So if you do a Groovy.comment in your code, when that gets parsed by the compiler, it'll actually be available for things like AST transforms or whatever. They can access that information and do additional things if they want. And other tools could be using it as well. So you can go and get the metadata, look for the one that's representing the comment and check that it's containing certain information and so on. If you go and put an @Groovy.doc annotation in one of your java.groovy.comments, then that's actually going to appear, this particular comment will appear in the bytecode inside an @Groovy.doc annotation. So it's basically captured at runtime. So if you go and have a whole class library and you put this there, then you won't need to go and have a separate Java.doc jar anymore. It'll all be available for inspection inside the one jar file. So it might make your jars a tiny bit fatter, but then they're self-contained, all the doco. And this kind of thing is kind of what Python and Ruby and other languages have always supported, this kind of feature, and that's how they tend to distribute the documentation that way rather than through the equivalent of Java docs or Groovy docs. So we can support both. Okay, so there's a whole lot of stuff that has been done, and there's a whole lot more stuff that's coming. And we're very, very thankful for the wonderful community that keeps contributing, but we're very welcoming for it. If you want to contribute additional stuff to Groovy, we'd be more than happy to hear from you, and yeah, more than happy to hear ideas as well. Okay, that's all I wanted to cover. Thanks very much. So I don't know if we've got time for questions or whether there's how we're going, but I can't see anyone. But where's Ivan? Have we got any time? Got a question? Yep, you yell out loud.
Yeah, I was just wondering when you use this collector annotation and you have several of the delegated annotations that accept different kinds of options, how does the collector find the right annotation to forward the options to?
Okay, so what the collector does is it just looks at the list that you've provided, and it looks at the list of annotations that have been supplied to it, and if the names of the annotation attributes and types match up, it just passes it through.
It finds several, passes them to...
All of them get it, yes. So if you do @canonical and you put excludes equals first, which is one of the examples I had, then that gets passed to the equals and hash code and the tuple constructor and the toString. Right. Now, if you don't want it on all three, then you can just put the toString yourself, like you used to do, and just put it on that one only. Yep, one more question?
About Grub VM. So in other language community, a lot of hype about this new virtual machine from Parrot. I was wondering if there is any plan also in the Groovy community for support.
There's none at the moment, but if there's enough interest, we would... Sorry, so say again which particular one you were...
Running Groovy on top of Android VM.
Oh, on the Android VM. So if you use compile static, you can run Groovy on the Android VM. It's just a little bit fatter than some of your other options. So if we had more time, we would spend lots more time making it slimmer. But we haven't, and whether we're kind of a little bit too late to the game now, I'm not sure. But certainly you can go and, there are Groovy applications that run on Android. You typically have to use compile static everywhere. And yes, we could make it a much more friendly Android working environment given more time. No other questions? Okay, thanks very much everyone. Thank you.